This is nothing but your textbook. This is the topics we are going to discuss today are in last class. Before going to that, I will just brief of the previous class topics. What we have discussed in the previous class, we have discussed about introduction of electrochemistry. What is electrochemistry? What are electrochemical cells? Particularly, we have discussed about galvanic cell construction and its working, the function of salt bridge, and then we have also discussed at the end of the class how a galvanic cell can be represented by using IUPAC nomenclature, IUPAC system. So those are the basic things that we have discussed in the previous class. So in this class, we are going to discuss a few more topics, and I will try to go little slowly. And if you get any doubts and all, you can ask me by unmuting yourself, because these topics are fundamentally very important. Uh, okay, we'll start. So just I will try to recall the previous topics, because our present topic is again based on the previous topic itself. In the previous topics, we discussed about galvanic cell. No, there in the galvanic cell, we have taken two half cells. Say, for example, this is zinc sulfate solution. This one is ZnSO4 solution, and some zinc rod is kept in zinc sulfate solution. This is zinc rod. Okay, this zinc rod is called electrode, and this one zinc sulfate solution, aqueous solution, this is called electrolyte. This solution is called electrolyte. Okay, this is electrolyte. This one is electrode. Remember, just here, what does zinc electrode contains? This is zinc metal, no? This is zinc metal. Zinc metal contains zinc atoms, zinc metal atoms. Iron metal contains iron metal atoms, right? And magnesium contains magnesium metal atoms. Copper contains copper metal atoms. Similar to that, zinc metal contains a huge number of zinc atoms. That means this rod consists of a huge number of zinc atoms. And what is this solution? This solution is zinc sulfate solution, ZnSO4 solution. Since this is a salt solution, can you tell me? You no need to unmute yourself, just to make you understand. Sodium chloride solution consists of what ions? Na plus ions and Cl minus ion. Sodium chloride is a salt. This salt solution consists of Na plus and Cl minus ions. Very similar to that, zinc sulfate solution consists of what ions? Zn plus 2, zinc ions and sulfate ions, SO4 minus 2. That means this solution, whatever the picture I have taken here, this consists of Zn plus 2 ions and SO4 minus 2 ions. And before that, what I said, this is a zinc metal. Zinc metal contains a huge number of zinc metal atoms. Now here, zinc metal atoms now dipped in, zinc metal is dipped in zinc sulfate solution. See here, this metal is dipped in zinc sulfate solution, no, here. Now zinc ions and zinc metal, these two are in contact. See, this metal rod consists of zinc metal atoms. Solution consists of zinc ions. Now when zinc metal atoms, see, when zinc metal atoms are in contact with the zinc ions, there exists some potential difference. There exists some potential difference. What is the meaning of potential? Potential means its power and its what to say, its energy or its strength. So zinc metal atoms have certain power, certain potential. Zinc ions have certain potential. So when these two are in contact with each other, there exists some potential difference. That potential difference is called electrode potential. Electrode potential. So, can you understand this electrode potential? How we can say, how we can define electrode potential? It's simply nothing but when a metal atom is in contact with metal ions, Where these metal atoms present? Metal atoms present in electrode. Where the ions are present? Ions are present in the solution. So when metal atoms and metal ions are in contact, when these two are in contact with each other, then there exists some potential difference. Okay, and this potential difference is called electrode potential. In the same manner, I am going to take a second example of copper. Let it be one vessel, beaker, and it is filled with copper sulfate solution, CuSO4 solution, CuSO4 solution. Copper sulfate solution consists of copper ions and sulfate ions. Isn't it? Now, I am going to keep one copper metal rod into this solution. What does the copper metal rod consist of? This copper metal rod consists of a huge number of copper atoms. When these copper atoms are in contact with copper sulfate solution, that means the ions present in copper sulfate solution consists of a huge number of copper ions. When these metal atoms and ions are in contact with each other, what happens? When copper metal atoms and copper ions, Cu plus 2 ions, both are in contact with each other, then there exists a potential difference. That potential difference is called electrode potential. Electrode potential. So now can you define electrode potential? So electrode potential, simply we can say it is a potential difference between the metal atoms and its own ions. Metal atoms and its own ions. See here, copper atoms and copper ions. When those two are in contact with each other, there exists some potential difference. That potential difference now we are calling as electrode potential. Right? So in the previous class, we discussed about galvanic cell. In that galvanic cell, we have discussed about two electrodes, that is copper and zinc. So the same thing I am going to explain once again here by showing in your textbook. See here, a potential difference develops between electrode and the electrolyte. Electrode means, what is electrode here? Here electrode is nothing but, in the case of zinc electrode, it consists of, zinc electrode consists of zinc metal atoms. Electrolyte means, electrolyte is nothing but zinc sulfate solution. Zinc sulfate solution consists of a huge number of zinc ions. So when these metal atoms and ions both are in contact with each other, there exists a potential difference. This potential difference between electrode and electrolyte is called electrode potential. I hope you understood this definition, because most of the students are unaware of what is electrode potential. So knowing these basic concepts is very essential. And similarly, suppose here one small case. Here see one more point is given here. Standard electrode potential. So what does it mean? Standard electrode potential. Just now we came to know that what is electrode potential. Then what is standard electrode potential? For example, whatever the copper sulfate solution I have taken in this vessel, beaker, if the concentration of the copper sulfate solution, listen carefully, the concentration of this copper sulfate solution is 1 molar. 1 molar means its molarity is 1. Then the potential difference arised between copper metal atoms and copper ions is called standard electrode potential. The word standard we get when we take 1 molar solution, electrolytic solution, concentration of electrolyte is 1 molar. Similarly, what is the standard electrode potential of zinc? Standard electrode potential of zinc, when we call it as standard electrode potential. Suppose if you take the concentration of zinc sulfate solution is 1 molar. Whatever the concentration, whatever the solution you have taken in the beaker, if the concentration of that solution is 1 molar, in such case, the electrode potential is called standard electrode potential. So I hope you understood, dear students. So if the concentration, is other than 1 molar, then it is not said to be one standard electrode potential. Just it is electrode potential. That's it. When we say particularly standard electrode potential, whenever we take the solution of 1 molar, here in the case of zinc sulfate solution 1 molar, copper sulfate solution 1 molar, you can take any other element. For example, if I take lithium chloride LiCl solution 1 molar, then it is the standard electrode potential of lithium. Similar to that, and if I take sodium sulfate Na2SO4 solution 1 molar solution, then you will get standard electrode potential of sodium. Like that, whatever the solution you take, if its concentration is 1 molar, under such condition, this electrode potential is called standard electrode potential. So this is electrode potential and standard electrode potential. Now, one more basic point, actually this we have already discussed. Once again, we will try to recall it. Anode, cathode. Most of the students get confused. What is anode? What is cathode? Simply, just to make you understand, I'll take whatever the statement given you in your textbook. So, the half cell in which oxidation takes place is called anode. The half cell where oxidation takes place is called anode. The half cell where reduction takes place is cathode. If you have textbooks, and you can also underline whatever I am underlining here, highlighting here, because these are the basic points. And if you can underline and you can revise the concepts very quickly in your revision. So once again, see here, what is anode? Anode means where oxidation takes place. Cathode means where reduction takes place. And once again, I will try to clear that concept. In the previous class, we discussed, sorry, zinc loses 2 electrons converted to Zn plus 2. Here this is called oxidation. If any one of you didn't attend the last class, and you can this is called oxidation. How can we know this is oxidation? Here zinc oxidation state is here 0. Here zinc oxidation state is plus 2. Zinc lost 2 electrons. Loss of electrons is called oxidation. If any metal atom loses electrons, then its oxidation number increases. This is called oxidation. Next, come to reduction. And where the oxidation takes place, that electrode is called anode. Suppose if any metal atom loses electrons and undergoing oxidation, then it is said to be anode. And similarly, copper, in the case of copper, Cu plus 2 ions, just opposite to that, gains 2 electrons and converted to Cu, metal atom, neutral atom. So here copper oxidation state is plus 2. Here copper oxidation state is 0. Plus 2 to 0 means reduction, reduce. Reduction means reduce. So oxidation state reduced from plus 2 to 0. This is called reduction. Reduction means what? Reduction means gaining of electron. Gain of electron. Okay, oxidation means loss of electrons. Reduction means gain of electrons. Just remember this. And the electrode which gains electrons, its oxidation state reduces, and that acts as cathode. Okay, these are the basic points. If you don't know, please note down and repeat it 2 or 3 times or 10 times till you get confident about this topic, oxidation reduction, because later in the coming topics, this part is going to be important to understand the concept. Now, come to cell potential. What is cell potential? So here see the cell potential. Cell potential is the difference between electrode potentials of reduction potential of the cathode and reduction potential of the cathode and anode. This is called cell potential. What is cell potential? The cell potential is difference between the electrode potential of cathode and anode. This is the definition. And this is also called cell electromotive force, EMF. EMF of the cell. What is EMF of the cell? EMF of the cell is nothing but cell potential. And just to make you understand, to make you clear, here I'll explain about this. My dear students, here you see Once again, I am repeating the same concept again and again. Okay, zinc, what zinc, how the zinc undergoes the process, whether oxidation or reduction. Zinc loses 2 electrons, becomes Zn plus 2. So this is oxidation. Since it is undergoing oxidation, since zinc is undergoing oxidation, it is called oxidation potential. Okay, na? Zinc has which potential? Oxidation potential. Why oxidation potential? It is losing electrons and its oxidation state increases from 0 to plus 2. So it is oxidation potential. Very good. Next, what about copper? Copper is gaining 2 electrons and converted to Cu. So gain of electrons is a reduction. So copper having reduction potential. So zinc is having oxidation potential. Copper is having reduction potential. Now, okay, what is galvanic cell? Galvanic cell construction and all we have seen in the last class, no? Let it be galvanic cell and it is having two different solutions, zinc sulfate and copper sulfate. This is a zinc rod, this is copper rod. Both are connected with external wire. Here one salt bridge. So this is all the arrangement, right? So here oxidation is going on, here reduction is going on. Here oxidation potential at zinc, sorry, it is zinc, this is copper. Here this is oxidation potential, this is reduction potential. Okay, na? Now, but scientists suggested that according to IUPAC system, they suggested that don't take oxidation potential and reduction potential individually for anode and cathode respectively. Instead of that, for both of them, you take reduction potential itself. Okay, you may not understand this point. Before going to that, I will give you one small formula. Now I want to know what is the cell potential. What is the cell potential? Now this cell consists of two half cells. This is one half cell. Copper, this is another half cell. Two half cells are there. Now if you want to know cell potential is equal to oxidation potential plus reduction potential. Oxidation potential of zinc, reduction potential of copper. This is the simple formula. So you can note down what is the EMF of this cell. EMF of this cell is equal to oxidation potential of zinc plus reduction potential of copper. So in this diagram, in what is the position of anode? Anode means this one, where oxidation is taking place. It's the left side, and where the reduction is taking place, it is in right side. This is left hand side. This is the right hand side, isn't it? So EMF of the cell is equal to E left hand side potential plus E right hand side potential, RHS. Okay, this is one formula, but this formula is not given in your textbook. Okay, whatever the formula is given, now I will explain you whatever the formula given in your textbook. But you also remember this when we use this formula, we use this formula when oxidation potential of anode and reduction potential of cathode is given, then we use this formula. This formula is very easy. Add oxidation potential plus reduction potential, you get total cell potential. Now come to the point. But scientists propose that you don't take oxidation potential of anode, reduction potential of cathode like that. You take reduction potential of both of them. Reduction potential of both of them. Then the formula will be somewhat different. So how it will be? EMF. You forget about your textbook. Now just focus on my explanation. EMF of cell is equal to electrode potential of right hand side electrode minus electrode potential of left hand side potential. This is the formula given in your textbook. All of you try to remember this formula finally, but this formula also you just keep in your mind. Whenever it is necessary, then I will tell you, and during our any numerical questions and all, then I will try to recall this one. When we need to use this formula we have to use. Actually this is uh, electrode, sorry, one second. What is this ERHS means? Right hand side means what? Cathode, no? Left hand side anode, no? See, left hand side anode, right hand side cathode. Here when oxidation potential of anode, reduction potential of cathode we need to use, then we have to use the above formula. Then this formula when we need to use reduction potential of cathode minus reduction potential of anode. Both are reduction potentials. Both are reduction potentials. Okay, in such case, we have to use this formula. Okay. So dear students, these topics are little bit dry only. I know that. But and moreover, explaining these concepts in a virtual class like this Zoom class is still more difficult because we are not in physical to each other. But try to understand. I am trying my level best to make you understand this topic. Here, one more point, one small example just to make you understand. Now, electrode potential of no oxidation potential of if oxidation potential of zinc is +1. Just to make you understand, I am giving this example. You can also note down. If oxidation potential of zinc is +1, then what is the reduction potential of zinc? What is the reduction potential of zinc? Is simply -1. That's all. That means if you know oxidation potential of any electrode, you can get its reduction potential just by changing the sign, just by changing the symbol. If it is plus, this one is minus. So one more question to you. If the reduction potential of copper is plus 0.34 volts, for example, what is the oxidation potential of copper? It will be minus 0.34 volts. Just this may be correct or wrong. You no need to worry about these values are correct or wrong. Just you try to understand. Oxidation potential is minus of reduction potential. See, reduction potential is plus 0.34. Then oxidation potential is minus 0.34. So likewise, we can easily find out the oxidation and reduction potential. Now, one more point and basic point. Any one of you can open your mic and you can answer Zn bar Zn plus 2. Can you tell me whether this is oxidation process or reduction process? Zn bar Zn plus 2. Whether it is oxidation or reduction. So if you don't know, I'll tell you very simply. See, what is the oxidation number of zinc here? 0. What is the oxidation number of zinc here? Plus 2. 0 to plus 2. 0 to plus 2 means oxidation number increased, no? Oxidation number increased. If oxidation number increased, it is oxidation. So this is the oxidation process. Now Zn plus 2 bar Zn. That means what? Zn plus 2 converted to Zn. Here oxidation number of Zn is plus 2. Here oxidation number of zinc is 0. Plus 2 to 0. Reduced. Reduced means reduction. This is the reduction process. If you want to write a reaction for the above one, first one, how do you write? Zinc converted to Zn plus 2. When zinc converted to Zn plus 2? By losing 2 electrons. Now, how would you like write a reaction for this one, second one? Zn plus 2 converted to Zn. That means Zn plus 2 converted to Zn. When plus 2 becomes 0? When you add 2 electrons. When 2 electrons are added, this plus 2 and minus 2 get cancelled and it becomes neutral. So this is called reduction. Okay, this is how you have to understand oxidation, reduction, oxidation potential, reduction potential. Okay, you no need to worry and you keep on listening, and whenever the situation demands, I'll try to repeat the same concept again and again, so you will become perfect. Now here here you can see some formula. So E cell is equal to E right minus E left. What is this formula? E cell is equal to means cell potential is equal to, see here, cell potential is equal to E right means right hand side potential. Right hand side potential is nothing but cathode potential minus left, right minus left. Otherwise, you simply remember higher value minus lower value, higher value minus lower value. Now come to the reactions. So what's the time now? It is around 9. Okay, hardly over 10 minutes is left. So let's continue. Here, see this reaction once again. Cu plus 2Ag plus gives Cu plus 2 plus 2Ag. So this is the reaction given. Now we have to understand which part of this reaction is undergoing oxidation, which part of this reaction undergoing reduction. See, my dear students, here copper, what is the oxidation number of copper? Is there any charge over the copper here? No charge, 0. What's the oxidation state of copper here? Plus 2. So 0 to plus 2, what does it mean? 0 to plus 2 means oxidation number increased. So copper is undergoing oxidation here. Copper is undergoing oxidation here. Okay. And now come to the silver. Ag plus 2Ag plus Ag plus means plus 1. Oxidation number is plus 1. What about Ag here? Product side. There is no charge. No plus, no minus over the silver here. So no charge means 0. Plus 1 to 0. Here Ag plus, here 0. Plus 1 to 0 means reduced, no? So that means this is undergoing reduction. Now from the given reaction, cell reaction, you have to identify, recognize which part of the reaction is oxidation and which part of the reaction is reduction. You can easily identify by seeing their oxidation numbers. Now let's divide this complete reaction into two half cell reactions. Likewise, in a first year, first year intermediate or 11th class, in the chapter basic concepts of chemistry, you have balanced the reactions. There you divide the reactions into two, like that only. So cathode reduction, which part is reduction here? This 2Ag plus becomes 2Ag, 2Ag plus becomes 2Ag. When 2Ag becomes 2Ag plus becomes 2Ag, here how many units of positive charge? 2 plus, no? 2Ag plus means 2 units of positive charge. So we have to add 2 electrons. So two positive charges, 2 negative charges get cancelled, and this becomes 2Ag. And similarly, copper, Cu becomes Cu plus 2. Cu becomes Cu plus 2. How Cu can become Cu plus 2? By losing 2 electrons. So Cu, after losing 2 electrons, becomes Cu plus 2. This is oxidation. So this is how you should be able to write the reactions. So if you are preparing for competitive exams and this part is important for you, you practice well. Still, if you have any doubt, you can let me know in our WhatsApp group. You message me and I will try to clear the concept. Next, dear students, now we have to write a cell reaction according to IUPAC system, as we have discussed in the previous previous class. So here copper is undergoing oxidation, no? That oxidation part we have to write first. Cu converted to Cu plus 2. Cu bar Cu plus 2. Between Cu and Cu plus 2, there should be one vertical line here. Next here, Ag plus becomes Ag. Ag plus becomes Ag. You no need to mention this 2 ma. This 2 you should not, you no need to mention. Ag plus converted to Ag. And between this and this, there are two vertical lines, parallel vertical lines. This represents the salt bridge. Between Ag plus and Ag, between Ag plus and Ag, there is one vertical line. This is the cell representation. In this cell representation, once again, this part is oxidation, this part is reduction. This is oxidation potential, this is reduction potential. But here we take only reduction potential. So what is the formula for cell potential? Cell potential, be careful dear students, cell potential is equal to right side potential, E for potential of the cell, electrode potential. Electrode potential of right side minus electrode potential of left side. Right minus left. What is right side here? This one is the right side, this is left side. So that means cell potential of right minus cell potential of left. That means cell potential of Ag plus bar Ag minus cell potential of Cu plus 2 bar Cu plus 2 bar Cu. Don't be confused. You may get one small doubt. Sir, here Cu bar Cu plus 2 is there. Cu bar Cu plus 2. because Cu bar Cu plus 2, but you wrote here Cu plus 2 bar Cu. Why sir like this? Because we are taking only reduction potential. Reduction potential means reduction potential means more oxidation state to less oxidation state, gaining of electrons. So plus 2 to 0. Here plus 1 to 0. Okay. This is how, just you remember these points. This is how we have to write the cell reaction and the cathode and anodic reactions and cell representation. First, from cell representation, we can able to write the electrode potential of the complete cell. All right. This is the topic. Dear students, the meeting may be ended within some 10 minutes. Okay, I'll see. And here, next topic is standard hydrogen electrode. Whatever you are seeing here, this is called standard hydrogen electrode. Standard hydrogen electrode. S, sorry, SHE. This is not she, standard hydrogen electrode. This standard hydrogen electrode is also called reference electrode. This is also called reference electrode. What is this reference electrode? Okay. Actually, if I ask you, you and your friend, if I ask you among you and your friend, who are more powerful, who are having more potential, who are having more energy? Suppose whether your energy is more than your friend or less than your friend, then what will be your answer? Generally, just by appearance we cannot determine who is more powerful and who is less powerful, and by keeping one small competition between these two friends, we can say, who, suppose among you and your friend, if you win the game, you will be more energetic, and you are having more potential. If your friend win the game, your friend will be more having more potential than you, isn't it? That means simply by taking one personality, we cannot say he is more powerful and that person is more powerful. By keeping some competition, by keeping some some fight or running race like that, we can say based on who win or who lost, isn't it? Similarly, if I ask you what is the potential of zinc, we cannot say potential of zinc just by orally. What is the potential of copper? What is the potential of zinc? What is the potential of iron? We cannot say their potentials just by taking individual cells. So scientists have uh, created some reference electrodes. One of the simplest reference electrode is hydrogen. Okay. So one second. Here you can underline this part. The potential of individual half cell cannot be measured. Potential of individual means potential of zinc, potential of copper, potential of iron. Like this, individual potentials we cannot be measured, but we can measure the potential by connecting them with some other electrode. So those are called reference electrodes. One of the simplest reference electrode is standard hydrogen electrode. And here I have seen the diagram, a small diagram, simplest diagram of standard hydrogen electrode. And now quickly I will explain its function and all. So within some 3 or 4 minutes, see here, this is standard hydrogen electrode. This is some vessel. This vessel is filled with hydrochloric acid, dilute hydrochloric acid, whose molarity is 1 m. 1 m molarity is 1 m. This is H plus ion. H plus ion you can see, no, the H plus ion means it is a H plus ion in HCl. We have taken hydrochloric acid, no, hydrochloric acid consists of H plus and Cl minus. So this is the H plus ion belongs to HCl. So the concentration of this HCl we have taken is 1 molar, right? Next, from here we are sending hydrogen gas, pure dry hydrogen gas at 1 bar pressure, atmospheric pressure, 1 bar pressure. Hydrogen gas we are sending through this way, and this is a platinum wire. This one is platinum wire, and at the end of this arrangement, here you can find this one is a platinum plate. So where I am showing no arrow mark, this is a platinum plate. So on this platinum plate, whatever the hydrogen gas we are sending into the hydrogen electrode, this hydrogen gas get accumulated over the surface of platinum plate. Now please try to understand my explanation here. Here we are sending hydrogen gas. No, this hydrogen gas come and absorbed on the surface of this platinum plate. That means this platinum plate, on the surface of this platinum plate, hydrogen gas will be present. Now that hydrogen gas is in contact with what? This hydrogen gas on the plate is contact with HCl solution. Actually HCl solution consists of H plus ions. That means hydrogen gas is in contact with H plus ions. Do you remember anything about this explanation? As just a few minutes back, in the beginning of this class, I told you when zinc metal atoms are in contact with zinc ions, there exists some potential difference. When copper metal atoms in contact with copper ions, there exists some potential difference. Those potential differences are called electrode potential. Likewise, we discussed, no? Similarly, here hydrogen ions are hydrogen gas. So hydrogen gas and hydrogen ions both are in contact. When hydrogen gas, hydrogen molecule and ions both are in contact with each other, there exists some potential difference. That potential difference is called electrode potential of hydrogen. Electrode potential of hydrogen. But scientists have taken this value. Scientist has taken this value as 0. What is the electrode potential value of hydrogen? It is equal to 0. Standard hydrogen electrode potential of hydrogen electrode is 0, right? That is arbitrarily it is taken, and you just remember this. And now actually just dear students, 1 minute is left hardly. uh, I may not uh, complete this within 1 minute because I don't want to go hurriedly. uh, shall you join once again, just for a few 10 to 15 minutes? After that I will conclude the meeting. Now this is a standard hydrogen electrode. This is actually 4 marks question for IP for Andhra students, and even for CBSE students also this topic is important. And if you listen these classes later in your regular second year course, you feel very easy because we are discussing almost a line to line of the chapter, and we are covering all the important concepts of this chapter. Okay, dear students, as I told you, 1 second, whether I have started recording or not. Yes. See here, and this is standard hydrogen arrow. This is the arrangement. Here, this is HCl of concentration 1m. So, what is this equation here? This equation is nothing but H plus ions. You try to understand H plus ions. From where this H plus ions we are getting? These H plus ions belong to HCl solution. Here, HCl solution have H plus ions and Cl minus ions. So these H plus ions gains one electron, becomes H2, half H2. Half H2 is nothing but, see, we should not write, see, hydrogen gains one electron, H plus gains one electron, becomes actually what you think. Generally, you will think that, sir, here H plus ion is there, here one electron is there, this plus minus get cancelled, and here we will get H. This plus and minus get cancelled, we get H. But we should not write hydrogen as monoatomic, because hydrogen will be always in diatomic gas, H2. We have to write H2. If you write H2 here, but we have taken only one hydrogen now, it will not be balanced. That's why we take half H2. Half H2 means this 2 get cancelled. Again, you get one hydrogen here. So half H2. This is half mole of hydrogen gas. So this is the that is the reaction given here. So try to remember this reaction. Next, here you see the cell representation. All of you write down this: platinum bar hydrogen bar H plus. I will try to try to explain this. So platinum bar hydrogen bar H plus. What is the meaning of this? And this is also important in many competitive exams. This representation is given in a different way. We have to write correct representation. So here platinum is there, no, platinum plate. So on the platinum plate, okay, if anything you are not audible, you are not visible, suppose you just tell me, just open your mic, because while explaining, while I am writing, I'm not looking at the screen actually. I'm writing on the board. So if you feel, if you get anything, something on the screen, you just please make me aware of that. Right, dear students. Here you see this representation. All right. Here platinum foil is there. Above platinum foil, hydrogen gas is adsorbed. So bar hydrogen. So this is platinum electrode and hydrogen gas is adsorbed over it. And this hydrogen gas is in contact with H plus ions. H plus ions of this HCl solution. So that is bar H plus. That is the meaning of this hydrogen electrode and representation of hydrogen electrode. Platinum foil, on the surface of platinum foil, hydrogen gas is adsorbed, and this hydrogen gas is in contact with the H plus ions of the solution. Okay, don't be confused. And some students will write like this: platinum bar H plus bar H2. This is completely wrong representation. Okay, be careful. And this is the representation of hydrogen electrode. That's all briefly. And if you have textbooks, you read this. Otherwise, you no need to have much more explanation regarding this. And finally, what I said in the just beginning of this class, what is the value of standard hydrogen electrode potential? Electrode potential value of hydrogen electrode. What is the value? It's taken as 0. Standard hydrogen potential value is taken as 0. Okay. So here there is a formula. See here, cell potential is equal to right hand side potential minus left hand side potential. So just before few minutes back we discussed, cell potential is equal to right hand side potential minus left hand side potential. Usually, uh, in some cases, this hydrogen is taken as a left hand side potential, means it is taken as anode. Hydrogen is taken as anode, and whatever the other electrode we need to determine the potential, that will taken as cathode. Okay, you may feel little bit bored here. Okay, I will take one small example to make you understand this concept easily. So, dear students, before that, I have taken one small example. If two friends are there who are more powerful, then we make some we will get have some competition, no, between these two. Who will be the winner? He will have generally more power, more potential. Similarly, now I have copper electrode with me. I have copper electrode. I want to find the potential of copper. Simply, I cannot find the potential of copper. So what I do, I take standard hydrogen electrode. This is hydrogen electrode. This is platinum wire, platinum foil, and here from hydrogen gas we will send. And this is the platinum foil. This is 1m HCl solution. This is hydrogen electrode. This hydrogen electrode is connected with a copper rod, and which is dipped in copper sulfate solution. Which copper sulfate is concentration also 1 molar. Now you see in the earlier galvanic cell, here we have taken zinc rod in zinc sulfate solution. No? So instead of that, what I have taken here? Here I have taken standard hydrogen electrode I have taken. And here voltmeter will be there. When these two are connected, here in voltmeter, you will get some value. So that value is nothing but the value of copper electrode. Why this value of copper electrode? Because the value of standard hydrogen electrode is how much? Value of standard hydrogen electrode is 0. This value is 0. Already we have arbitrarily taken. It's a fixed. Then whatever the answer we get, that is the answer. That is the value of copper electrode. So practically, see here, practically when scientists have conducted this experiment, they found that the copper, one second, uh, the value of copper, they found that, where it is, yeah, it's here. The value of electrode potential of copper is 0.34 volts plus 0.34 volts. This is the practical value determined by the student, sorry, scientists. Sorry, scientists. What is this? This is the electrode potential of standard electrode potential of copper. This value you fix in your mind. Similarly, if you want to find the electrode potential of zinc, what you have to do? The very similar to the previous one, you find here you take, this is standard hydrogen electrode and it is connected to, let it be zinc rod this time. This one is zinc rod. Zinc rod, this is zinc sulfate solution and concentration is 1 molar. When zinc electrode is connected to standard hydrogen electrode, then there will be some potential difference. This potential difference is nothing but standard electrode potential of zinc. What about this standard electrode potential of copper, sorry, hydrogen? It is always 0. So whatever the value we get, that value belongs to zinc. So standard electrode potential of zinc is, that will get something. So when this experiment is conducted by the scientists, so we got its value is minus 0 point somewhere here, minus 0.76 volts. So standard electrode potential of, that is reduction potential of zinc is minus 0.76 volts, right? So these are the two values, and I will continue about these reactions and all in the next class, because this, I feel that this class becomes very lengthy, and moreover you may be little bit you feel little bit bore of this class if I go through these reactions and all. I will continue from this, and but before that I would like to show you what is the cell potential. Now just now what we have calculated, just now we calculated the standard electrode potential of, copper, Cu plus 2 bar Cu. What's its value? Plus 0.34 volts. Similarly, we have come to know that electrode potential of zinc, its value we got minus 0.76 volts. Now, if I tell you, we'll come to the first example, galvanic cell. Let it be, this is zinc sulfate solution, this is copper sulfate solution, zinc rod, copper rod, both are connected, and here voltmeter, and it is 1 molar concentration, this is also 1 molar concentration. Now I am asking you, what is the EMF of this cell? What is the EMF of this cell? EMF of this cell is equal to electrode potential of right hand side cell electrode minus electrode potential of left hand side electrode. So what is there in right hand side? Right hand side is copper sulfate, no? Copper. What is the value of copper? Copper standard electrode potential is what? 0.34 plus 0.34 minus, what is the left side potential of, left side potential means zinc potential, no? Zinc potential is minus 0.76 volts, minus 0.76 volts. Okay, that is equal to, actually this is a plus 0.34 minus of minus 0.76, minus of minus becomes plus, no? 0.34 plus 0.76, the total potential will be 1.10 volts. So that means the battery or cell, galvanic cell, obtained by combining zinc and copper, this type of galvanic cells potential will be, total EMF of the cell will be 1.10 volts. This is how we find, we can find the EMF of the cell. So again this explanation is given in this part, but I will continue from this probably tomorrow, and I will let you know the timing of tomorrow's class.